What about chemical contaminants of concern? Well, industry uses a wide variety of things, and depending on the site, those things can end up in the groundwater. But there are some more common ones that we encounter in geology, groundwater geology. Uh, One of them is petroleum hydrocarbons from handling petroleum at filling stations, but also in the refining. The most common in the groundwater are the BTEX compounds. They have an benzene ring in them, aromatic hydrocarbon, benzene, toluene, ethylbenzene, and xylene. There are volatile organic compounds, particularly the chlorinated solvents like trichloroethane. Sometimes it's also referred to as trichloroethylene. Um, the trichloroethylene was used to take grease off of metal parts. If you're going to take a metal part and grind it and cut it, you're going to have shavings and filings on the metal part. You need to have heat. You use oil to get the heat away from the grinding process, and then now you're left with the shavings and the oil on the part. So you have to get rid of the part of that. So you use a solvent to get rid of the oil and clean the parts off. And then you follow that with chrome plating. So that brings me to heavy metals. Um, Chromium 6 then is oftentimes used to plate the metal. So I used to say, show me a site that did metal finishing, and I'll show you a trichloroethylene and chromium 6 problem. But the chromium 6 has other sources as well, involved in transformers and things like that. So in fact, the Hinckley, California case was chromium 6 from electrical equipment. Lead is commonly coming from plumbing. I already mentioned that if you stick water with pH less than 7, it can mobilize the lead that's already in the pipes or used in the solder on the pipes. This was the case of lead in Flint, Michigan. The source water, when they switched to the Flint River, the source water had contaminants as well. It's not clear to me how much of that was the problem and how much of it was in the plumbing, but I do know that the water that went into the system was more acidic, and that caused lead to be mobilized from the old water mains. And this can be a problem in older communities. You got to make sure that the water does not mobilize the lead in the plumbing. And utilities will oftentimes add bases to the water to raise the pH to keep that from happening. Landfill leachate is another source of heavy metals, particularly cadmium, lead, and nickel from batteries and e-waste. But you can think of anything we throw in the landfill as potentially something that can dissolve and get into the groundwater system. And like I said, the industry uses a lot of different things, and sometimes they're using new and different things. And so we discover problems that we didn't know exist before. In California, one of those was perchlorate. And it was discovered in the early 90s that perchlorate was a problem in a lot of drinking water. In California, there were two sources for the perchlorate. One of them was agricultural perchlorate because it had been imported with Chilean nitrate fertilizer used in the citrus, and the perchlorate was natural. It was natural. It accumulated in the deposit, the nitrate deposit that was mined for fertilizer. But then there was also a rocket fuel. Ammonium perchlorate is manufactured as a rocket fuel, and so there were human sources of industrial sources of perchlorate as well, and these have contaminated regions in California. A new emerging contaminant example is the discovery of pharmaceuticals in water. And this kind of brings up the whole issue of water recycling. Sometimes some of the treatment systems that we use, especially if they're not tertiary treatment systems, really just chlorinating and flocculating and things going in the settling ponds, and not really sophisticated forms of wastewater treatment. Maybe not even involving filtration or ozonation or any of these tertiary treatments. And sometimes these are not effective in removing pharmaceuticals, which end up in wastewater treatment plants. Then the wastewater ends up in the river, ends up in the groundwater, ends up back in in the river downstream and is pulled in by a water utility, which treats the water, but oftentimes all they're doing is a large amount of filtration to remove the animal life that we talked about, as well as uh, uh, disinfecting, but they may not be doing treatment, at least really fine reverse osmosis to remove things, that larger molecules like pharmaceuticals. So sometimes these pharmaceuticals will get into the drinking water. Brings up the issue of water recycling. The statistic I like to quote is something, I think it's in California, the water droplet will go through a kidney 9 times before it reaches the ocean. And one thing that might become an emerging contaminant is the new craze in nanoparticles. So the small-scale molecular compounds that can do neat things because they're really small, but they could also end up being contaminants in the groundwater or in the water supplies. And we'll see. So the whole emergent contaminant issue is to keeping track of what new contaminants are that are coming along or maybe ending up in the water supplies. And the last category of things that might be in water are radiological contaminants. They're not usually a source of significant concern, but what are some of the sources? Nuclear reactors, obviously, and possible leaks or radioactive gases or radioactive fluids. The atomic testing era, much of the radiation that ended up in the atmosphere, for a while we had tritium in the atmosphere and carbon-14 in the atmosphere that we were actually able to use to age-date groundwater from the last time it had been in contact with the atmosphere, because it would decay and give us, by the count of half-lives, how old the groundwater was. And of course medical waste. The medical waste would be low-level radioactive waste. The nuclear reactors would be higher. Atomic testing is obviously residual from the bomb testing programs. That would be generally high-level radioactive waste. I mentioned atmospheric tritium and carbon-14. With the underground testing, tritium is significant in the groundwater. The hydrogen in the water makes the water radioactive itself. There are some daughter products to heavier daughter products related to the testing that are in the groundwater as well, but for the most part those are solidified, or they have been incorporated in a lot of the rock material. We're lucky to see that they're not moving that far. So we have heavy, relatively stable daughter products that can result from nuclear fission of uranium. The most common are iodine-131, which gets into the thyroid and emits radiation in the thyroid. So it can be blocked after a nuclear accident, which is why you see people taking iodine tablets after a radioactive release, and that if you saturate your thyroid with iodine, it'll block the radioactive iodine. Cesium-137, quite common in the soils after nuclear accidents. Strontium-90 and cobalt-60. All are emitters of at least 1 or 3 kinds of ionizing radiation. The alpha particle, which is essentially, all these things are coming out of the nucleus now, so they're a little bit different than chemistry, but it's essentially a helium atom with the electrons taken off, so it's ionizing because it's got a net 2+ charge. The beta, again, is kind of like an electron, except it's higher energy and comes out of the nucleus as part of the nuclear decay. And lastly, gamma radiation, which is a wave, an electromagnetic wave. When I give this presentation in public, at this point I usually conduct a taste test. Have people compare bottled water with tap water. Tap water raw has one taste, category, tap water treated with just filtration, removing the chloramines and the chlorination compounds that are part of disinfection, then compared to various different kinds of bottled waters. Water utility water is, people claim they don't like it, but I try to prove that if you do these steps to make it taste good, refrigeration, filtration, it can be as enjoyable as bottled water, perhaps more so. The water utilities in the United States really are, they say, the seventh engineering wonder of the world. One of the seven engineering wonders of the world is the water distribution system in the United States. And it's unfortunate that things like Flint really the American public loses its trust in the water utilities. That's perhaps one of the leading tragedies coming out of Flint. Because the water utilities in general, if they're not being corrupt or taking shortcuts, they're required to meet and report hundreds of MCLs, maximum contaminant levels, to U.S. EPA standards. So the Environmental Protection Agency sets these standards for the maximum allowable contaminant levels in groundwater for all of the categories that we just looked at: bacteria, chemistry, radiology, and this is in accordance with the Safe Drinking Water Act. At this point, I mentioned emerging contaminants, and the Woburn case, it goes back to 1980. Back then, the Safe Drinking Water Act, which was passed in the middle of the 1970s, did not have trichloroethylene on it, because one of the questions I asked early on in that incident, having read the book of Civil Action, why was the water utility serving water with trichloroethylene in it? Because the court case went after the two potential sources of the TCE, but not the water utility for serving it. And the answer is the water utility was not required to test for TCE. But it's been added to the list now, and many contaminants have been added to the list since. And the MCL list is well over 200 compounds now, and the water utilities are required to measure these weekly and report them to the public. Bottled water in the United States is regulated by the Food and Drug Administration. It's like a soda pop or something being sold over the counter as a food or beverage. So it's monitored by the Food and Drug Administration, considering that most of the bottled water is coming out of tap water anyway. The tap water is probably meeting EPA standards, and the bottled water then is meeting EPA standards, as well as being regulated by the Food and Drug Administration. But the Food and Drug Administration does not do as thorough a testing as the water utilities. The other advantage that bottled water has is again, disinfection with ozone and UV. And as I mentioned earlier, that does not leave residual disinfectant in the water, so the taste from disinfectant is gone, but it doesn't leave any disinfectant in the water afterwards to do any kind of disinfection of possible contaminants that come along later. That concludes part 3 of my presentation, What's in My Water and Where is it From? Tune in for part 4, where we'll discuss the two main sources of water for Southern California in terms of energy of production.